Alrighty. Good morning again. All right, we got a couple things today. We're going to finish up chapter 5 on methods and validating data. So we got through pretty much everything in methods for our first examples. And now we want to look at how we can validate data so our program doesn't crash, because that is fantastic, right? Anytime you're using a program or an app or something and it crashes, it's just super frustrating. I don't know why that's like so irritating, but if you do end up writing software that people use out in the world, nothing gets it a bad name faster than it crashing a lot, right? And then people are gonna not want to use it. You'll get bad reviews if it's an app. So dealing with the exceptions here is huge. And we can also do some data validation along with that, which is really nice. So let's see, we had our morning for methods. Get that open here. Right, so then we're going to finish up chapter 5. The chapter 4 quiz should be due tonight, 11:59 p.m. Right, and then I'll post the chapter 5 quiz after class. Make notes so I don't forget. Quiz.
We're not seeing chapter 4 on the quiz.
Is it not there?
No.
I should have posted it last week when we finished it. I did not. Oh, crap. All right. I'm sorry. Yeah, it should have been there. Well, that's not good with our schedule then. I don't want to skip it because I want you to have seen the questions. Then doubling up is no fun. Okay, hang on. How are we doing on time here? I'm sorry. This is why I have to leave myself notes. Let's see. We've got a little bit of time. Okay, so let me post the chapter 4 and 5 quiz today. And 5. Right, quizzes. And then if you need a little more time on those, I can give you a little more than a week. Will that make up for it? Apologies. All right, so how about like 10 days on those? All right, I'm sorry about that. Should all be automatic. It's not all automatic. Not automatic yet. Okay. So we'll finish up chapter 5. Hey, it's October. That's right. Happy October. Yeah, all of the trees are changing colors already, which is, I mean, they're not slowing down, I guess. We had that like cold week in September, and then it warmed back up again. But all right, yeah. So we're gonna keep cruising. We are officially in the middle third of the course, but essentially this last like 5 weeks here, the numbering is all off a little bit, but is just Java FX. We do the chapter out of the textbook. I spend a bunch more time working on other examples, showing other things in Java FX. So this is essentially, we're halfway through the main content. We'll pick up the second half of the content here through week 11, and then our graphical user interface applications. We'll sit there for 3 weeks working on these, and then the final project work time, I have no plans to actually talk at all. It's just for you folks to get together. Ideally, you work in pairs. I get we're still kind of in the middle of a pandemic, so if you'd prefer to work individually, I get it. It's not a problem. Generally, you'll get a better product with more people working on it, and it doesn't like scale. You can't be like put 100 people on it and get 100 times better product or anything, but at least like having 2 people, you can bounce ideas off of each other, talk about approaches, and kind of think through what's happening. think through your design. But it does cause a little bit more work with the coordination. So whether or not you're individual or in a pair, it's the same project, right? Because if you're doing it individually, you don't have to do any of that collaboration effort. You don't have to do, be managing who's updating what. It's not super hard with GitHub or Git to work on the same code. It's actually what it's designed for. It's for people to collaborate on code. But it adds a couple other steps. And they're not too bad. So as we get closer, we'll talk more about how we manage that in Git. But yeah, so we're cruising. We're cruising. All right. So chapter 5 in methods. So we've done a couple here, right? We've done void methods that don't return things. They just do their code and then they stop. And again, methods can call other methods. So you can go as deep as you want to with this. A method will call a method, will call a method, will call a method. There is some limit, but essentially we don't care. Not too big of a deal. And then there are methods that return types. So if you're not a void method, you're a value returning method and you'll give something back. So we say, okay, I'm going to give you back an integer. And we use this return keyword to give a value back. So any type that we want to return, right? We've done ints, we did doubles, did strings. Sure, right? No, we can return those from our methods. And methods are essentially really good for 3 reasons, right? The first one is it puts a name to what's happening. So we can kind of see just in our main method, like, okay, we're doing this, we're doing this, we're doing this, we're doing this. We just see naming wise what's happening without even having to look at any code. Right? I think that's the underappreciated bit. Usually what we like to say is it also will help you not have duplicate code. Right? If you want to do the same thing more than once, well, you just ask the method again. Right? And it's not even exactly the exact same thing, because what we're allowed to do is say, okay, hey, you will give me an argument here. So if you want to run this method, you have to give me a value. So the method can do something with that value, right? So our little quadratic formula, right? If you give it A, B, and C for our formula, we can calculate your first x-intercept. Sure. Right? You give me A, B, C, we'll do the math here. So any A, any B, any C, and we're going to try and do the arithmetic. With our prompts here, we say, okay, hey, you tell me what you want to ask the user. Right? Usually we'll say enter a number, and usually we want to give them a range. Like, what sort of range should you enter here? Again, the more you give the users, the more likely you are to get better results. Right? If you just say enter a number, you're going to get some smart software engineer who's like, oh, I'm going to give you 4.2, and you're expecting an integer, and you're going to crash. Right? So, and people will do dumb things. Users do the weirdest things to our programs that we don't expect. There's actually a whole specialty in software engineering called quality assurance, or QA. Their job is to make your job as a developer miserable. And that's a joke. So their job is to make sure your software is high quality and doesn't crash when they throw weird stuff at it. And the kind of people who are good at quality assurance are really good at that sort of outside the box thinking, like, okay, I know it says this, but what if I type in this? Who knows what's going to happen to the user? Or I've had on several occasions, I'm in the middle of something and my cat jumps up on my desk and my keys go poof, and stuff gets typed. That happens. We had one case, we had a web application, and we do some monitoring to make sure, like, hey, if a particular user tries to log in a bunch of times in a row, it sets off security flags. That's relatively common. And it happened to somebody, and like we looked it up, we looked at logs, like, hey, they tried to log in like 200 times all of a sudden. Well, that's not right. So they send a note over, and the guy had no recollection of trying to log in 200 times. So we're like, oh, well, that's no good. So they reformatted his whole computer. Turns out he just put something and something fell over on his enter key, and it was just spamming login and the enter key. So people will do weird things, right? And quality assurance is all about making sure that if weird things happen, our program doesn't do badly, right? It can at least respond gracefully to that. So part of that is this validation of data. So when we ask someone for a number, and they type out 10, T-E-N, 10, it's not a numeric 1, 0, and Java is not going to handle it, right? So if we ask them for a number, we just run our program here. I think I'm over this tab, right? Changed around my tabs. No, I can't find anything again. Yeah, this will be the right tab. Okay, so enter a value. So if I enter 10, it crashes. The big red ugly crash. I think we've probably seen this before. Right, and this is called a stack trace. Have we talked about that? So what it's doing is it's spitting out exactly where it was when it crashed. So remember when we run in debug mode, we can see, hey, I was at this method main at this line, and then onto the call stack goes the next method. Okay, now I'm at this method, this line, and then this method, this line, so that it knows where to come back to when it's done. We talked about that. That's what this is. So we were at main at line 13. We went to ask the user for a number at line 40. And then this is part of the Java library. We actually went into the Java library code at line 778, line 660, at line 67, and we got a number format exception. So when you get a crash like this, it actually prints out the stack trace. It says, oh, okay, here, this is where we were. This is what was happening at that time. So that's why we have to read it kind of from the bottom up. Because our stuff starts at the bottom. All the Java library stuff we have no clue about. I mean, technically you can go open it and look at it if you want. Right? It's all out there, but it's going to be mostly gibberish to us. What we care about is at the top, what the exception was, and where the last part of our code was that we left off. So here at line 40 is the last bit of our code before it crashed. So that's where that crash was. So if you click on it, it's actually like a little link. It'll take you right to line 40. Hey, it crashed when we tried integer.parseInt. Right? All right, well, let's fix that. Let's make this not crash. Sound good? Okay, so to do that in Java, we have a new keyword we're going to use. So it's called try, which I really like. Like, we're going to try this thing. It might crash, but we're going to try it. So you start a try block. You put in try and a set of curly braces. Anything that might crash goes into the try block. Okay, and then at the end of the try block, we catch. You say, okay, I'm going to try this. Now, if an exception happens, I want to catch it. Imagine like someone's throwing it at you. When we go do our own exceptions later on, the keyword is actually throw. So it's throw an exception and you catch an exception. So we're going to catch. And then inside of the set of parentheses, we have to tell it what do we want to catch. So I know from that stack trace, it was a number format exception. So I want to catch a number format exception. Format exception. And I'm just going to call it EX here. So it's short for exception. If you want to spell out exception, great. You're in a catch block. This one's relatively straightforward. That means exception. Generally, I don't like abbreviations, but this one's pretty clear. So if we get a number format exception, we want to catch it. So this will keep us from crashing. So instead of crashing, it goes to our catch block here, and we'll do whatever code it says we want to do here in catch. Cool. All right, so what do we want to do? We can tell them that's not a number. Please try again. Now, the problem is now it's upset with our return number. Remember, anything that's declared inside a set of curly braces, our technical term for that was the scope, right? It only essentially exists in Java inside the set of curly braces. So outside that set of curly braces, number doesn't exist. So we can't return number because it only exists inside this try block. Okay, so we've got a couple options here, right? Because we want them to try again. So hopefully as soon as we say try again, you're thinking, oh, we need some sort of loop here, right? We got to try again, right? Go back to the top, do it again. Go back to the top, do it again. Go back to the top, do it again. So a couple options. One I'm not quite so fond of, but it works. It's just awkward maybe. We're going to say while to start a while loop. And here's the really ugly thing. You just say true. And that means we now have an infinite loop. Right? This thing will run forever because true is always true, literally true. You can't change true. So what we could do then is inside of our loop here, after this line of code runs, we can add in the break command. Right, break, remember, we'll stop the loop, hard stop. As soon as we reach break, loop's done. Sure, we could do that. No, we still don't know what number is. Okay, so to fix that, we just need to tell Java up here, oh, I want an int for number. And inside the block, we don't need to declare it a type of integer. We just say, hey, remember that number thing I wanted? Now give it a value, please. So we're moving the declaration, so we're just telling Java, hey, I'm going to use this in a minute. And that way, we've declared it at the same level here, at the same scope, so that we can return it here. Right? Remember, if we declared it inside the while loop, it only exists inside the while loop. If we declared it inside the try block, it only exists inside of the try block. So this one's a little ugly, right? Because we got this while true and a break. It's not the prettiest thing, but this is actually relatively decent. Not too bad here. Don't feel too bad about this in general. And because the other thing that happens, as soon as an exception occurs, the code stops running in the try block and it jumps to the catch block. So if we get that number format exception here, this line 43 doesn't run. As soon as the exception happens, it causes a jump to the catch. Because something bad happened, now let's go to our handling. Let's go catch that exception and deal with it. So if the exception happens, we skip this line. Right? That's probably worth noting here. So there is an exception above. Break is, it jumps right to the catch block. Okay, so exceptions cause the try to stop. So this line, we won't reach it if that exception happens. If there is no exception, we set number, we give it a value, and then we break the loop. Our while true loop is done, and we can return. We're in pretty good shape. Okay, a different option here is you could just say, I want to return number. Same idea. If we return, right, the loop stops because this method is done. There's no more anything to do as soon as we hit return. Some people think returns in the middle of methods are ugly. You know, it's just a style preference. This is relatively straightforward, and we're not doing a whole lot of things after the fact. So again, it's probably fine with that sort of style here. So you could just return in the middle instead of having the break. Right? This would also stop the loop here. Now, it's upset about this one. It says it's unreachable. We're never going to get here because Java can recognize we have an infinite loop. It says, hey, nothing stops the loop. This line of code will never run. Well, yeah, we know that. That's okay because we're going to return in the middle here. So, sure. Right? We don't need the return down here. So then we could put int number. We could declare it back inside the try block if you wanted. Because we're going to return it right away in here instead of declaring it up above. Right? So we could move that back down and just say, hey, here's my int for number, return inside that while loop. So a couple different ways of going about it. Either way is fine. Kind of like this, just to return. Then I don't need the return down below. So the while true loop's a little bit ugly. You feel a little bit bad about it, but that's what we're doing. We just want to run forever. Right? Until you give me something that actually parses as an integer, you're not allowed out of here. Right? You can type away all you want. Give me a million different things. Until it's an integer, you're stuck. Because the code can't do what it needs to do until it has an integer. Right? So great. So a couple options. So this try and catch is how we handle our data, or handle those exceptions from happening. Right? So if we know a bad thing could happen, we're going to go check it. Now, because reasons, the scanner class, remember, it can do, instead of just next line, you can ask for things like next int or next double and all those sorts of things. I don't recommend it, right? Because it causes trouble later on down the road the next time you want to do a next line, because it leaves the enter key hanging around. If you did go down that route, though, it has a different set of exceptions. It has an input mismatch exception. So if you really wanted to use scanner and do the other examples, again, the book will do it. It'll show you how. Instead of saying it's a number format exception, it's the other kind of exception, the input mismatch exception. I don't know why they're different. Right? I don't know why we have too many of those, but that's okay. Yeah, awesome. Cool. All right, yeah, mismatch. Yeah, try and catch. Awesome. All right, so that one is good. This one is using our other method already. So this is the number in bound range, which still uses ask the user for a number method. So just adding that one try catch block in here, right? Because we used this method in all of our other ones. This is just a generic prompt. This one was asking them for a number between, which we set up for the range here, right? And we generated our own prompt, and this one was just for fun. So, okay, if you tell me the high and the low, I can come up with my own prompt, enter a number here just to be helpful. And then this one, if you give me the prompt, you give me the low and the high, we'll figure out what it is. This was a little silly. Like if you don't want a lower bound value, we said, okay, if you just give me the minimum value, sure. Right, I can deal with that. We had other sort of loops happening to do some checking here that was assuming you gave me a number back, right? Because we can't check if a number's bigger unless you actually got an integer back. So all that depended on we actually being able to get a real integer out of our method here. So we wrote methods that use methods that use methods and just had some fun with it. That's sort of the goal, right? Once you have a nice helper method, like ask the user for a number, you could take this and copy paste it into any other project that you do that asks the user for numbers. Again, there's better ways to do that sort of thing, but we don't know them yet. So don't worry about it. Right? We could just copy paste to the next project. Right? And that way you've got, hey, this one already does all the this already does all the validation. It's all nice, ready to go. Right? If you want to use the range things, great. We can use any of those too. Right? I think we did copy those over for that shell example we did, right? For the project 2. So hey, let's just copy these over. Okay, so you don't have to do the exception handling. There's no points for that in the rubric, right? We've modified this one now. If you want to use the later version, great, not a problem. Right? You use either one because we weren't required to deal with any of these. The next project we have will be required to do these try catches and not crash if I give you bad input, right? But again, we hadn't got there yet, and that's okay. But this is really nice to not crash the program when people give us weird things. It's really helpful to not crash. People just think your program's not very good if it crashes on them all the time. So we got the scanner. This number format exception is the same if we're doing integer or double. Right? Integer.parseInt or double.parseDouble. So the same exception type here. Okay, so the same try catch will work, right, regardless of what we're trying to parse. The same idea here. And again, generally you do it in some sort of loop, right? So if we didn't have a method to do that prompt here, right, and we just had something out in main, right, we couldn't do a return, right, because we want it to continue on. So the other option you have when you're building out loops like that, right, so let's just, I'll just ask them to enter a double. So we'll say, to make your loop stop, you could use the break option. And if you want to avoid breaks, we could use a flag. So we'll say, hey, I've got a double for some value. I'm just declaring it now. It doesn't have a value yet, right? I'll just say, okay, I'm going to use one later. And then I'm going to make a Boolean flag that's true or false. So I want this to be true until I've gotten a good value, right? So I don't know, like needs input still or something. We'll say is true. So I'm going to loop while we needs input still. So we'll say while needs input still. Is that there, just, it's not an expression, it's just a Boolean value here. It's either true or false. So then we can prompt them for a value. We'll enter a number with the decimal place. Sure. And then try. Right, so we'll try that some value is scanner or keyboard dot next line, and we have to try and convert that. Double dot parse double. Oh, it doesn't know what keyboard is. So these static values that you can use in any method, right, we can also put scanner up here. So I can say, hey, I want a scanner. I'm going to call it keyboard equals a new scanner given system.in. Oh, but I need those other keywords. So public static here. Static. So if I use a class level, right, it's defined outside of the methods. At the class level, if I declare this scanner, I'm going to call it keyboard, I can use it in any of my other methods. So I don't have to redeclare another one. Where do we even do scanner? That was up here. So we can get rid of this line if we wanted, because we did it up above. And again, so if you're going to share something among all your methods, you can put them as class level variables. It is technically ugly, bad form, but we don't know how to fix that till next chapter. So don't worry about it. Right? We can do it, and then we'll look at a better way next chapter. All right, so I got my sum value, right? And then I can say, instead of a break here, I can say needs input still is false. And then my catch block will catch the number format exception. Call it EX. Say that's not a number. Number, try again, please. Sure. Then eventually down here, right, the loop will end because we've set this to false. And all this just to avoid a break. Maybe it's not even worth it. And breaks aren't that ugly, but sure. And we can say, I don't know, you entered plus some value. And it's actually going to yell at us here. It says some value might not have been initialized. Remember, we declared it here. This is initializing it. This is giving it its value. But it says, I have no way of knowing for sure that this actually happened. It's not that smart. You can't tell that, like we can tell, you're not getting out of the loop until we get a value here. Right? It's kind of a bummer. So it can't tell. So we'd have to give some value a starting value, right? So that it knows, okay, it had a value at some point. We know we're going to overwrite it here with whatever value the user enters. Right, but it can't tell. So if we use the break keyword, no, it still doesn't work. I thought it picked that up. No. So did it fix it? Did that fix it? Maybe it did. I just have to click out somewhere. Nope. Sometimes it's smart enough if it catches a while true and a break. Yeah, there, that's what it is. If you use a while true with a break, you notice it stops complaining? I didn't have to give it a value initially, but it can recognize this particular form, like a while true with a break. It knows, hey, that thing's going to run forever. If it's just a Boolean value, it's not smart enough to check to see, hey, the only time you ever changed it is after this inside of a try block. But if it sees while true with a break, it knows, okay, this has to happen eventually. So the little bit of code inspection that the compiler does there can recognize this, but it can't recognize our flags. So maybe that's a benefit, but you know, it's not too bad to just use the flag here, that one. So we just have to give it a value, like starts off at 0, sure, and then it'll go away. So just be aware if you're doing these sorts of loops, right, for these little validation loops, great. Now, it'd be nice not to have to do this every time, right? Now you can see why it'd be really nice to have that out in a method. Like, hey, enter a number. I don't have to type this over and over and over again. right? We've got a method for it. And again, ours previously was integer here, ask the user for a number. So we'd have to make a new method, like ask the user for a double, and do that. But we could do that, right? We could have another method. Technically, you can have the same method name twice, 3 times, 4 times, 5 times, as long as the arguments or parameters are different. Again, don't worry too much about it. We can get more into that later when we talk about other chapters where it will make more sense. But I can't say, hey, I want another one that returns a type of double with the same name and parameters. That one's not allowed for reasons. So if I change the name of the method, great. That's okay. How are we feeling on methods? It's going to take some practice, right? So we did that shell for the project. Here we go. We said, okay, this is what it might look like with a bunch of methods, right? That not really any code in here, right? Sure, we got a little while loop, okay. But we're doing, okay, we broke it down step by step by step. It's that process of functional decomposition. It's one of my favorite technical terms, right? Taking a big problem and break it down into smaller and smaller and smaller steps, right? That's the third reason methods are great. It lets you take a big problem and say, okay, I want to focus on this small piece. And I want to focus on this small piece. And I want to focus on this small piece. And focus on this small piece. I don't care about the rest of it for now. Right? I'm going to tackle one little bit at a time. Right? So, okay, as long as we want to keep on playing, let's go. So instead of a do loop, again, I hate do loops. So I use a while loop that I know is going to run. Just because I'm weird. Sure. So we'll ask the user for the word to guess. Great. Ask the user for a number within the range. Right, whatever your particular prompt happens to be, right? Give them a nice message. This is that method we stole. We didn't even steal, we copy pasted, right? And like we cited, oh, I didn't even cite my source. I should have cited my source here. We copied it into the whole, did we copy it into the whole? I didn't even put it there. I did above. Okay. So we could go find that URL, right? It's GitHub, CIS 1500. Fall 2021. I should set a better citing example. I'm sorry. So our chapter 5, our methods here. We'll say, come down to our little method here for ask the user for a number. And look at that. I'll say from here. And this one too. From here. Right? That's all we need for a citation. Right, so this is where I got the code from. Again, I'm expecting that to happen. So like, I'm not going to care if you took mine, but just get into the habit, right? Oh, hey, we used some code that was already written. Here's where we got it from. That's a citation, right? There's no APA or MLA format for code citations, right? We don't do that sort of nonsense. Just tell me where you got it from, okay? All right, so we asked them for a number, and then this, are we still playing? Like, did we solve it yet, or did we die? Hang the man? That's the hangman game is a little bit gruesome for children. They're like hanging stick figures, and we think nothing of it. Like I never really thought a lot about that until like I was playing with my kid. And they're like, "Why are you drawing that guy, Daddy?" Like, this is what you do. That's how you play the game. And yeah, okay, that's weird. But it's our children's game for reasons. Okay, so display the word to guess with blanks. Right? If they haven't guessed the letter yet, display a blank. If they have guessed the letter, display the letter. Right? Display all the previously guessed letters. Cool. Ask the user to guess a letter. Cool. And we keep on doing that while we're still playing. When we're done, ask if they want to play again. If it's a guess, right? Cool. Or a Y, we'll keep going. If it's anything other than a Y, this is false. The loop stops. We're done. We had fun with Hangman. So a couple things we had to do, right, with dealing with characters. So I thought did we have that in? We did it in loops from the previous chapter. That's right. So it was in this one here. It was in chapter 4. Let me zoom that in a little bit. Whoa, too much. Too little. Too much. Too little. Too much. Sorry. It's weirdly fun to zoom with the mouse. I don't know. That's control and mouse wheel will usually do zooming for you if you hold the control key down. So this little loop here, right, is how given some sort of string, like we said name, to char array, to character array, and for each character we're going to call a letter in that name. We'll do something at a time. So it's going to get one at a time every character out of that string. Right? So if I have a string that is the word you're supposed to guess here, I can loop through, right, one letter at a time. And if I have a string that has all the letters you've guessed, I can loop through that one inside of this loop. Right? You can put a loop inside of a loop like we did when we were printing out our pretty little shapes. If you loop inside of a loop, right, you can check for every letter here, check every letter here, see if there's a match. Right? If you've guessed it, we print the letter. If you've gone through all the characters you've guessed and you haven't found the letter we're looking at, print a blank. Does that make sense for that approach? Right? It's a loop inside of a loop for how we can figure out our letters. There you go, in our shell here. Right? Because we have this, we don't even have the string in here, right? We'd have to track the string of all the letters that they've guessed, right? We know what our word to guess is, so we probably also need this as like a class level variable, or we could pass it in as an argument. Either way, generally passing things as arguments is probably cleaner, but I know that can get a little funky here. So we could pass it two things. We could give it the word to guess, right? And all the previous letters we've guessed. But again, like when you ask them to guess a letter, then we have to do something with it, and we have to add it back to another string. It can get a little funky here, right? So maybe we had a string for letters guessed, right? It starts off as empty. And when we go ask them to guess a letter, maybe it returns a letter, right? So we could take our letters guessed string. We can say, hey, I want to add that letter in, right? String concatenate, right? Remember, the plus operator doesn't really plus, it doesn't add things, but it'll take the next string and stick it on. So ask the user to guess a letter returns a string here instead of being a void method. If it returns a string, or even a character, right? Either one's probably fine. I think string will be easier though. For now, we're just going to return nothing so that the method doesn't crash, like it'll compile. Right? We can then take whatever letter they give me back and just smush it right in here. Guessed with two D's. There we go. Letters. Gust. I can't spell, friends. Guessed. Okay, that looks better. Guessed. Sure. And the same, display the word to guess with blanks. If you wanted to, we could pass it both the word to guess and the letters we've guessed. Right, so we just say, okay, when you call this method, you need to give me the word to guess and a string for letters guessed. Gust. Guessed. I can't. Need more coffee, friends. Right, we can use arguments to say, okay, you can give me the string to avoid having to put all these things as static values. And either's going to be fine for us. We're not too concerned that this is ugly right now. It'll definitely get the job done. And that's what we care about. Is it functional? Right? As you learn more, we take more coding classes and you practice more, you'll learn more the better habits to do things that are good practices instead of the ugly ways. But again, we've only been doing this for 5 weeks, so not expecting Picasso. Right? Just while we talk about Picasso, made me remember. Have you heard about the rule of 10,000 hours?
Yeah. 10,000 hours in the math.
Yeah, so for anything that you do, ever, they say it takes about 10,000 hours worth of practice to master that. Right? Whether it's painting, whether it's a sport, whether it's coding, some subject, other things that people do. People have hobbies. You guys have hobbies, right, in real lives? Okay. If you want to master your hobby, right, it's going to take you 10,000 hours to do it, which sounds like a lot of hours, but if you consider a full-time job, 40 hours a week, right, times 50 weeks a year. Again, you're hopefully getting some vacation in there. That's 2,000. So that's only 5 years at full-time work to master something. And like mastery level is a really high level of understanding something, right? It's not like, hey, I can do this. It's no, I've mastered the subject, right? So who was it? Was it Malcolm Gladwell? Was that his book about this? And he looked at famous people? I feel like it was. Okay, yeah. And turns out Bill Gates was just like at the right place at the right time. His dad knew somebody. I forget the whole story. So like he was working on computers already for this guy that his dad knew, and he had access to a computer that like most people didn't have computers back then, didn't have access to, so he was able to master it early on thanks to all this practice. Just some good circumstances. So yeah, it takes a lot of time, a lot of practice to get good at something, right? And you don't spend necessarily 40 hours a week in your particular subject in school, right? You might if you're taking all CIS classes, right? 12 credits is 12 hours in class, 24 hours outside of class at 36 hours a week on average, right? For 12, if you're taking 12 credits of CIS courses, that's one semester, right? And this is years full time, but again, you'll get there. You'll get there. It'll just take a little bit of time. So definitely recommend the practice. I'm going to give you the projects bigger things to try and put them together. Mr. Tim sent me a great note. He said he had a couple people come to study group, which definitely encourage you to go Tuesdays and Thursdays, 1 to 2. Tim's fantastic for the group study times. You can also book individual appointments through the Academic Sports Center with him, or Rika is our tutor. And did you tell me he's got hours out at Royal Oak that aren't the Orchard Ridge hours? Okay. I don't know. Each of the campuses works differently. I'm sorry. Like we each have our own Academic Sports Center department. I'm not in charge of that. I'm sorry. It's crazy. But if you just ask him individually, he'll probably tell you when you can book and who to ask. Because honestly, I can't keep up with it. I guess we could just go look at all 5 of the links for their schedules, but that feels like a lot of work. Yeah, but go to the tutoring sessions. But he said he told somebody who was asking about the project and said Eric likes to give vague projects that make you go figure things out. And he's like, and I mean that in a good way. Like he wasn't trying to make me feel bad. And that's sort of the goal, right? Like if I say do the thing and all you have to do is like copy paste a couple lines from the textbook and change it, that's not good practice. So the goal is, hey, here's a bunch of tools in your toolkit. Let's go put them together to solve a problem. So it's supposed to take some of that process. And really, that's the hard part of computer science, is how do I solve a problem, not how do I write the code. It's taking a big problem and breaking it down into smaller and smaller and smaller steps and figuring out, okay, well, I do this step, and then I'm going to do this step, and I'm going to do this step, and I'm going to do this step. Then we write the code to do it. Right? If you spend some time designing ahead of time, planning out your approach, it's a lot easier than just jumping right into the code. So there's a whole cool process of writing what's called pseudocode, which is it's kind of like code, and it's essentially like the detailed step by step by step. So pseudocode is not specific to any language, right? It's just the steps. So if you write a good enough pseudocode, like, hey, go do this, 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 someone can take it and solve it in any language. Right? We're learning Java. Other people could do it in C. People could do it in C#. People could do it in Python. Right? The language shouldn't matter if the pseudocode is here's the step, here's the step. And that's what we were trying to do with these method names, right? Do this step, 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 do this step. We're off to the races. All right. I think that's all we've got for chapter 5. So we got the rest of today to work on this. This one's due, we got a week from today, right? That I put in D2L. Oh, D2L was down that day, right? Last week? Mm-hmm. Okay. I have a good excuse now why there was no quiz. I remember, okay. It's all coming back now. Yeah, so next week, 10 a.m., right? So I'm happy to help you, right? But please don't wait until Sunday. All right. I have very limited availability. I'm happy to meet with folks later at night, usually after my kids go to bed. But I can only meet with like 1 or 2 people. that's the whole night, because it just gets super late. And then nothing before class, typically, right? That's breakfast time and second breakfast time. If you're a hobbit, you got to get both breakfasts in. But we got all week, right? We got the rest of today. On Wednesday, again, the goals, I'm not going to try and talk all 2 hours. We'll have time. Ideally, we practice the new stuff, but yeah, if you want to be working on the project too, we can knock that out as well. So hopefully by Wednesday, after we're done in person and you walk out the room, ideally you're done. Then you don't have anything to worry about for the weekend. So, but you know, life happens. We'll work with the schedule as is. So let me know how I can help, and we can go from there. Online chat was real quiet today. Just you, I think, Wolf. So if you got anything, if you're remote, just ping me on Discord. I'll be hanging out on Discord, walking around the room, helping people out. Yeah, so we'll take a couple minutes here. I'll go grab a Coke, and then we got work time the rest of the morning. Cool. Thanks, folks. Take care, everybody online. Oh, we got 2 Wolves in chat. Wolf Shadow and I Am Wolf. Look at that. I like people's online handles. I think those are fun. All right, take care.